Have you ever taught a math concept to a kid and you reteach it, reteach it, reteach it, reteach, and it just doesn't seem to stick with the kid? Like they've mastered it one day and then a week later you revisit it and it's like they're seeing it for the very first time. This is a very common problem that happens in within the elementary and middle level mathematics class. So what I'm going to be doing is I'm going to be giving you a brief overview of a model that really helps students gain a conceptual understanding about mathematics and helps them remember what they're actually doing. The model that I'm referring to is called the CRA model in mathematics. Let's take a look to see what CRA stands for. C stands for concrete. So at first you're using blocks and tiles and other hands-on tools in order to do the math problem. Then you're going to be moving to a representational model for R, and that's using drawings and pictures and models in order to solve the problem. And finally, then you move to the abstract, which is where you bring in the numbers and the equations and the algorithms and teach the students how to use them to solve the problem. The CRA model is a highly researched and found to be highly effective for the way of teaching mathematics. This stems back its origins kind of with Jerome Bruner, working off of Jean Piaget's idea of the three types of learning, which is physical, social, and mathematical. He comes up with this way, Bruner does, of a linear path to learning new mathematics. It's very systematic, and that's the CRA model. And there are numerous studies that have also been done and research that prove that it is an effective model. For example, Kennedy, Mansell, and Miller, they had said that students who rely on memorizing procedural steps and lack of conceptual understanding related to foundational operations will not understand why steps are used. So it's really important that we build that concrete understanding of the process of mathematics. Also, there was a study done by Butler, Miller, Graham, Babbitt, and Pierce in 2003 that showed that in a control study, students with disabilities receiving the CRA instruction performed as well as the general education eighth graders on all fraction assessments. And they actually outperformed the general education students with word problems that had fractions and equivalency embedded in the problem. This particular infographic really helps me understand how the CRA model is supposed to work. So notice how you're starting off with introducing the math concept, right away going into the concrete, moving to the representational and making that connection as you're moving over. Same thing, making the connection between the representational to the abstract. And lastly, notice how it's then connecting all three of the concrete, representational, and abstracts together for the students so that they can make sense and understand that all of them is representing the same thing, which then gives them that flexibility to use concrete, representational, or abstract when they're going ahead and solving that problem, which is going to help them have that deeper understanding in mathematics, which is what we're really aiming for in math right now. Let's take a look at a couple examples together. So here is a third grade math concept of the expanded form. So recognizing that the number 342 is really 300s, 4 10s, and 2 2s. And you break it apart with the concrete, the hands-on base 10 blocks, then representational with the pictures, and then lastly you see the connection with the abstract. I actually just realized the abstract is wrong because the 4 should really be 40 because it's 4 10s, not 4. Here's an example of using the CRA model in fifth grade to help students see equivalent fractions. In this concrete model, you'll see that there are 6/9 of the chips are pink. What's really cool too is if you have the students look specifically at the rows, you see that 2 of the 3 rows are pink. So 2/3 is the same as 6/9, which is hard for students to understand if you just go strictly to the abstract model. So notice how the concrete and the representational then drawing the pictures, you see how they are done in black and white, and then connecting that to the abstract of, okay, if I have 2/3 and I have 3 times as many of the chips, then that gives me 6/9. It's the exact same thing. Working with integers in sixth grade can be a really challenging contract for students, especially when teachers jump directly to the abstract. You'll see this model represents -3 plus 5 equals 2. So you can use the chips and see that if I have negative, the negatives are represented by the blue and the positives are represented by the green. And you see that there are 0 pairs that cancel out to be left with 2 positives, which is represented in the representational picture, a little bit more clearly with drawing the negative signs and the positive signs. This CRA model is often not used in the higher level grades, but you can see how it can be very, very powerful for students to truly understand what is going on when it comes to the abstract. Christina, who is in charge of the Build Math Minds professional development experiences for teacher, uses the CRA model in a different way. So instead of looking at it as a linear path where you start with C and move all the way to A, you're looking at mathematics and you're trying to find that sweet spot. So you can see that if you can do all three of the CRA in the same activity, students are going to be able to make a better connection between the concrete, the abstract, and the representational. And so she doesn't believe you need to follow the CRA in a specific order, but sometimes you'll have concrete, other times you'll just do abstract. Sometimes it'll be representational and abstract, while other times you might be looking at concrete and abstract. Either way, making the connections instead of following the sequence, she believes, is better than the regular CRA model. Jeannie Curtis, an elementary teacher who has the blog Elementary Math Consultant, really utilizes the concrete CRA model, and she says how it's important that we emphasize to students the flexibility to help students with problem solving, that students need to know that when you're solving a problem, it can either be solved concrete, representational, or abstract, which means if a student is struggling to come up with the abstract model, they can turn to pictures and other things to help them understand the problem, which really gives them a great support system for mathematics. Some teachers say it takes too much time to go through and do all of the hands-on things. The students are distracted with the manipulatives anyway. They just play around with them and they don't really see the connections between the concrete and then the abstract. Also, we don't have the time to teach all of the content in depth for deep understanding, conceptual understanding. We have all these topics that we need to cover, not enough time, so we just skip right to the algorithms because that's what the kids need to know. It's the faster way anyway. Also, it's not very easy to facilitate. If you have 30 students in your classroom and you're looking for them to move items around to represent a problem, it can be very hard to go around and monitor to make sure every student is on task as well as really understanding and doing the math correctly. It can also be expensive. If you don't have the manipulatives in your classroom, it gets costly. And so how are you going to be able to do the CRA without the C part? Also, it can be frustrating for the students who already know that they grasp the concept and can get answers quickly using the abstract algorithm. It is fun to note, though, that those particular students, if you ask them to go back and explain how they know each step works, most of them do not know. They are actually just really good memorizers. So does that make them a good math student, that they can answer a question really, really quickly? Or does that compared to somebody who may be able to do a math problem with the concrete model and be able to explain, but take a much longer time to do that process? The advancement in technology and the emergence of the accessibility of technology is really, really beneficial for the CRA model, because instead of needing to have all these manipulatives stored in your classroom, what's great is you can use the online manipulatives. A lot of them are free in order to do the concrete models. For example, Think Central, which is from Hardcore. They have counters, base 10 blocks, number lines, and so forth. Another really cool one is Glencoe Virtual Manipulatives, a free program. You can select the grade level. They have placemats for the background, so you can have a place value chart as well as base 10 blocks or anything else. There's also Splat Online, which is an interactive website to recognize patterns in the base 10 system. There's Math Learning Centers, which is an app-based manipulative resource. So all of these are excellent resources for you to find virtual manipulatives. So in the end, the CRA model is a really effective approach in teaching conceptual understanding of mathematics. And online virtual tools makes it possible for anyone who has access to technology to do that for their students. So instead of wasting the time in class reteaching the algorithms of the abstract approach, go ahead and try the CRA model and see how that helps your students retain the information you're trying to teach them.